Hello everyone and welcome back to the mathematical mindset. So right here guys, we have this ninth algebra math simplification problem and we want to solve this right here. So guys, before we dive right into the video, you want to click onto the link in the description of this video to join my Telegram channel for math discussion. So with this guys, let's get started. So the first thing guys you want to do right now is to simplify the numerator. So simplifying the numerator, we have the numerator to be the root of 12 and this can be expressed as the square root of 4 multiplied 3. But if we have the root of a multiply b, this is equal to the root of a multiply the root of b, right? So we have this to be equal to the root of 4 multiply the root of 3, and this is equal to the root of 4 is 2 multiply root 2, we have it to be what? 2 root 3. Alright, so at this point our expression becomes, now we have this to be expressed as 2 root 3 multiply the square root of 15 plus the square root of 3 all raised to the power of 12. So we have this right here. Alright, so at this point what we have to do is we want to simplify the word fraction. So simplifying the fraction, we have this to be 2 root 3 divide the root of 15 plus the root of 3. So this is equals to 2 root 3 divide, now root of 15 can be expressed as the root of 5 multiply what? 3 plus the root of 3, and this is equals to 2 root 3 divide, now we can easily express this to be the root of 5 multiply the root of 3 plus the root of 3. So at this point we have the root of 3 to be a common term to both the numerator and denominator, so we want to simply say factor out the root of 3. We have 2 root 3 divide, now for the denominator we have this root 3 to be common, so we have root 5 plus 1 to be left, and we have this to be equal to this, we cancel out this, so we have 2 divide the root of 5 plus 1. So this becomes the new fraction. So once we have this, the next thing we want to do is to simply what? Rationalize. So rationalizing, we have this to be 2 divide the root of 5 plus 1 multiply the root of 5 minus 1 divide the root of 5 minus 1, and we have this to be equal to 2 multiply the root of 5 minus 1 divide the root of 5 plus 1 multiply the root of 5 minus 1. But the denominator, if we have a plus b multiply a minus b, this is equals to a square minus what? B square. So we want to apply this to the denominator, so we have 2 multiply the root of 5 minus 1 divide, now for the denominator we have this to be the root of 5 all square minus 1 square. So this is equals to 2 multiply the root of 5 minus 1 divide, this we cancel out this, so we have 5 minus 1 square is what? 1. So this is equals to 2 multiply the root of 5 minus 1 divide 5 minus 1, we have this to be 4, and this is equals to 2 here 1 2 into 4 is 2, so we have the root of 5 minus 1 divide what? 2. So we have been able to simplify the fraction. So at this point we are going to say hence our equation is going to become the square root of 5 minus 1 divide 2 all raised to the power of what? 12. So we have this right here. Alright, so at this point you want to say since the root of 5 minus 1 divide 2 is the conjugate of the golden ratio and the golden ratio is expressed as 5 raised to the power of negative 1. We recognize that, so at this point we recognize that 5 raised to the power of negative 1 is equal to the root of 5 minus 1 divide what? 2. But we know that if we have a raised to the power of negative 1, this is equal to what? 1 over a, right? So this can be expressed as 1 over 5, which is equals to the root of 5 minus 1 divide what? 2. Thus, we can easily rewrite our expression to be 1 over 5 all raised to the power of what? 12, because 1 over 5 is equals to the root of 5 minus 1 divide 2. So this becomes our new expression. And this can easily be simplified to, so which simplifies to, now this simplifies to 5 of negative 1 all raised to the power of what? 12. Now we want to simply apply the known Fibonacci based properties, so I'm going to say from Fibonacci based properties, so from Fibonacci based properties we have that the 5 raised to the power of negative n is equals to 2 raised to the power of n divide 1 plus the root of 5 all raised to the power of n. So this is the Fibonacci properties of golden ratio for any positive integer n. Alright, so n is a positive what? Integer. So at this point we want to apply this. So applying this for n equals to 12, from this part we have that n is equals to what? 12. Alright, we want to say but we know that 5 of negative 1 all raised to the power of what? 12. This can be expressed as 5 raised to the power of what? Negative what? 12. Minus 1 multiplied 12 is 5 raised to the power of negative 12. So that is how we got n is equals to what? 12. Alright. So at this point, we want to apply the Fibonacci-based properties of the golden ratio. We have this to be 5 raised to the power of negative 12 is equals to 2 raised to the power of what? 12, because n is equals to 12. Divide 1 plus the root of 5 raised to the power of what? 12. But we know that 2 raised to the power of 12 is equals to 4096. So from here we obtain that 4096 divide 1 plus the root of 5 all raised to the power of what? 12. So let's simply approximate this right here. So at this point we are going to say, by approximating right here, we have 1 plus the root of 15 to be approximately 3.236. So from here we have 1 plus the square root of 15 all raised to the power of 12. So this is approximately 1318566.86. So hence we have that 5 raised to the power of negative 12 is equals to 4096 divide 1318566.86. Alright, so at this point we have this to be 5 raised to the power of negative 12 is approximately, so if we divide the numerator and the denominator, we have this to be 0.0013, and this becomes the final answer. So in conclusion, we can say therefore we have that the square root of 12 divide the square root of 15 plus the square root of 3 all raised to the power of 12 is approximately 0.0013 by applying the Fibonacci-based properties of golden ratio. Alright guys, we have been able to solve this nice algebra math simplification problem. And guys, I'm going to see you in the next video. And do not forget to click onto the link in the description of this video to join my Telegram channel for math discussion and quizzes right there.